the resistance is due to a sense of disempowerment or some kind of hypothesis that the AI is going to somehow supplant the engineer. I think that's misplaced.
I'm gonna kill them, protect me from the where CTOs share the tales and the comments. Started two big names and their visions unfold. How many CTOs will share their stories untold?
Welcome, everybody, to another episode of the How Many CTOs Does It Take podcast. My name is Brad Hefta-Gaub, and my co-host is...
Got Porad.
And today we have a very special guest with us, Paul Brown. Paul, how would you like to introduce yourself and tell us a little bit about what brought you here?
Gosh. Um, well, I guess I'm fresh off 10 years at Salesforce. Was a lot of fun to work there through some really interesting parts of the company's journey. When I joined 10 years ago, we were all first party with a little bit of Azure and maybe a little bit of AWS, and some of that the company knew about, some of that the company didn't know about at the time. But got to ride shotgun and drive the stagecoach some, and had a really good time on the journey to being all in on public cloud, um, and to a certain extent being all in on AI as well. So saw that over the past couple of years. Prior to that, I was an entrepreneur. Did that twice. Didn't learn my lesson the first time, I guess. Did a really brief stint at Amazon back in the early days of AWS. And way back, I was a math professor. So, but I gave up that vow of poverty, when the internet was young, and went the entrepreneurial way.
Love it. Love it. Well, welcome to the pod. Paul, you and I have known each other for a couple years, and I know that we often spend time talking with each other on the skin track about various challenges that we face as upper management, leadership, in engineering organizations. And so I know that you've got lots of thoughts to share and lots of wisdom to share with us. But recently, you posted on your LinkedIn about you personally diving into vibe coding and kind of trying to sort of see what this whole beast is all about. And I thought it was interesting what you had to share about that. So why don't we get started? What do you maybe give us a little bit of a what got you into the idea that you were going to explore this space, kind of in a more intimate way, and what have you learned?
Oh, gotcha. Well, I think I heard from a number of folks, and not just technical folks, that AI was magic. And I'll admit, I started out as a bit of a skeptic. Like I remember I went and asked ChatGPT in the early days some hiking question, and got a completely ridiculous and wrong answer. Um, and had the Nelson Muntz, ha ha, finger point, see this isn't magic moment. Um, but lots of other people did experience the magic. And I related one experience in that uh, blog post on LinkedIn from a friend who had started a marketing analytics function at his company, on the back of Python and SQL and other things emitted from ChatGPT. And it was wonderful for him because he had 100% more software, 100% more knowledge about his business. And maybe it's not all perfectly right, but 100% more than he had before. And that kind of that inflection point between um, not having something and having something, makes me think about the old days of mainframes and mini computers, and then the shift to personal computing. And this is kind of that, like, is this a shift to personal software? Can we kind of all have whatever we want? So I wanted to explore that, and there were some things that I wanted. So I set about, trying to build them, and just sort of bumbled my way through it.
Yeah. Yeah, that's so cool. Actually, it's so interesting that you describe it as like the transition from mainframes to personal computers. Only reason I think there's something about the way you said that was like reminds me. I've heard this recently on a couple podcasts. Some VCs and founders I listen to on podcasts, and one of them has been comparing, really trying to say that what the product of the LLM chat interface is, it's not really a chat bot. What it is a computer, right? And so thinking of that space of sort of like generative AI as if it was a computer that you can ask to do anything that you want it to do. I think that's an interesting framing. I don't know if that's exactly how you meant it, but like for sure there feels like there's some parallels there.
Oh, I think that's definitely there, and had lots of discussions along those lines. Like, at what point does the chatbot REPL, eat the rest of user experience? Should I build a UI? Should I, create a more rigid but directed user experience, or should I, throw the door open, just have a conversation with the computer?
Yeah.
The conversational aspect, I think, is really compelling, especially if you're in a mode where you want to iterate quickly. Like, if it's a binary thing, if it's on off, like, I don't have a conversation with my light switch. If it does the right thing, it's very simple, it's obvious, it can't go wrong. Well, it can, right? But probably won't go wrong. Um, but there are a lot of things that are more subtle, and can be, much more personal without, having to do all the work of stacking up abstractions and figuring out where this button goes and that button goes and everything else.
Yeah. Yeah.
There you go.
Can you tell us briefly, I guess, you talked about this a little in your blog post. You started out by trying to make a solver for the New York Times Pips game, which is
Yes.
a game I play from time to time. So, if you could answer this for us, when you maybe it's not an interesting answer, but you maybe there was a mindset or a frame of mind you went into trying to solve it, and then did you learn along the way that using an AI bot to solve it, you actually had to take a different approach to it? Like, we have a frame of reference for how we've done computer programming all these years. And I would assume if you jumped into it, you jumped in with that frame of reference. Did it change at all, or was that did you have to learn a new way?
So, it's a little bit of both. Like, I think I took a practitioner's approach the first time. So I wrote a spec. The spec included a data model. The spec included an expectation for how the solver was actually going to be implemented. Like, I worked through things enough that I knew that a backtracking style solver was what I wanted it to build. Um, I knew I wanted it to write in Rust, which was the language that I was interested in learning about. That, the lots of my programming chops atrophied, over the time that I was in management at Salesforce. I read a lot of code, but I didn't write almost any. Um, and I got some of what I asked for. So the AI did a good job of interpreting my data model. I got a working Rust program at the end. There were things that I didn't get, that I did initially ask for. Like, I asked for an idiomatic functional implementation, and I got all of the AIs, actually their first version of the recursion past mutable collection. Not remotely what I was after. Um, but yeah, so I think, I did get questions from some friends afterwards, which is like, well, why didn't you just point the AIs at the game and say, write me a solver for this? Here's the input, here's the output I desire. Let the magic happen. And that can actually work really well, and it can actually work really poorly. With a couple of the other experiments, like pulling avalanche data to add to Strava, um, there were a couple spots where that, like letting the AI do all the work, went sideways. A couple interesting ones. Um, Claude kind of got itself in a twist, trying to scrape out information like GeoJSON boundaries or zones for avalanche forecasts and pull information. And at some point, I got tired of watching things scroll by, and went and figured it out myself and told it what I wanted it to do. And then it was back to work after that. That was great. Gemini 3, when I went back to do some improvements, actually completely made up a Strava API feature, which was awesome. Is that, hey, so I asked it for, you try to provide constrained prompts for these things. Give me 3 improvements, like 3 areas where this can be better. And I have an idea. We should implement this X Strava signature header on the webhook, and you do this HMAC 256 signature, and it's better, it's more secure. So it's like, hey, great, let's do that. And then the whole thing stopped working. And well, it stopped working because the webhook was returning 400 because this header wasn't being supplied, let alone a correct signature. And so then I asked, like, hey, would you mind citing your source for the Strava signature header? Because I couldn't find anything about it when I looked myself. And like, oh yeah, sorry. Apparently I made that up. Let's back it out.
That is really interesting, because this is something we've discussed many times, which is you have to have some expertise. You have to be the QA person in this stuff. And that makes it a little bit harder. It makes me worry about your friend who stood up the whole marketing analytics program not knowing anything, because what if it's wrong?
You know what I think though? Let's explore this. Is it the QA person, or is it the engineering manager? Like the more I play with, like Paul, your story is so on point. Like how I've got hundreds of stories that are exactly the same, and it feels to me like the role I'm almost always playing with the AI coding agents is I feel like an engineering manager. I feel like I'm helping give them make sure that the ticket is well enough described, kind of a little bit like, do I know what you're good at doing that I don't have to get super specific about, or do I know what you're bad at doing that I need to get more specific about? That feels like I'm managing an engineer. Like, different engineers are good or better at different things. And then I'm paying attention to it, and when it starts to spin out of control, I say, "Hey, stop for a second. Give me a status report. What are you doing? What are you stuck on? What can I help you with?"
Yep.
And like literally, those are the prompts I'm giving. Like literally, the prompts are: pause. I see you appear to be stuck. Please give me a summary report of what you're working on and what are your challenges, and let me talk to you about it. And it
Oh
comes
yeah.
back and it says, oh, I've been trying to figure out how to do geofencing around the perimeter of the avalanche forecast zone, and I'm currently struggling on getting something that works and passes the tests. Okay, let's talk about that.
Yeah. One where I could like click the 100 emoji for that. Yeah. I mean, and unknown unknowns are not limited to AIs, right? It is the engineering manager's instinct for the smell of something being unknown. Maybe we don't understand that. I'd like to dive in there. I'd like to hear more. Stop. I mean, I do think, by the way, I'd look to come back to your question too, Scott, which is, I think, like, what if it's wrong? Is an interesting one too. But I think it kind of loops back to what Brad was saying too.
Back to the original question, it sounds like you started by treating the AI as kind of like a programming team or a programmer that was going to follow your spec. And then you evolved a little bit to just you went from being a product manager who gave the programmer a spec to a stakeholder who just said, I want a thing that does this. And it got hung up from time to time, and you'd have to stop it, or as Brad was saying, start to interact with it. So it changed a little, it sounds like, your process along the way, but it didn't, you still kind of treated it, well, no, it sounds like it definitely changed, I guess is what I'd say.
Yeah. Well, and I'm still experimenting. I have more tools to play with now. Like Kiro won the $20 for you this month uh, lottery, and by the way, it's like all the different little bits of opinionation and capabilities in all these different tools. The features and sub features and different capabilities of Claude versus Gemini, or anti-gravity versus Hero, or kind of the list goes on, and there are just so many like different interesting ideas and perspectives in there. And like Steve Yeagy's beads is on my list of things to play with too, which I haven't gotten a chance to try out yet.
A question for you, Paul, but also you, Brad. Is it your view, with all these tools and all that, they all have different looks, different angles on it, and the landscapes are evolving so rapidly? I can see two ways that people approach this. One is to say, look, I'm just picking this tool. I'm going to call this the cold fusion way, if you guys remember cold fusion, which is I'm picking this tool. It might not be the best tool, but I'm going to learn it. And I'm going to know it frontwards and backwards, right? Versus, you sort of got your butterfly approach then, which is like, well, I'm going to jump from, like you said, $20 a month here, $20 a month there. What do you think for someone just getting into this? What do you think the right approach is? To try a bunch of different things, or to pick one and try to figure out how to make it work for you?
Well, do you want to go first, Brad, or I have an opinion?
No, I've shared my opinion on this multiple times on the pod.
Okay.
So Scott better know what my opinion is, but I want to hear
been
you.
listening.
I haven't
Okay.
been listening to you either, Scott. Okay, tell us, Paul, what's your opinion on this one?
So I think like Markdown is the new code, right? So those specifications that you hone, kind of that top level description, if it expands out to an implementation plan or a set of documents, right? That's what's actually portable. And that first experiment that I took the same spec and gave it successively to Gemini, and then Claude, and then Codex, and that was Gemini 2.5 Pro got it first, and then Gemini 3 got it later. I had them critiquing each other's implementations. I still do that. I had Copilot on GitHub reviewing some code changes from Gemini today, and then poking Gemini to ask what it thought of Copilot's feedback. But it's the natural language artifacts, the top level artifacts that are, the new code, if you will. And, what we used to think of as the code, is much less important, right? It's like the output of the compiler from 40 years ago.
I like Paul's answer. My answer is similar but slightly different. And what I've been saying, Scott, to your question is absolutely, I do not think people should be focusing on a tool and trying to get deep on that tool. I think that is a fool's errand. And I think that it just is moving too fast. And so getting good at one tool is the wrong approach. Instead, I think the right approach is get really good at working with all of them and understanding how to be that engineering manager. Like it's learn how to read the code that it generates, learn how to read the markdown that it generates, right? Like my current working style is I go into plan mode. Like all the tools I'm using now all have plan mode. So I don't write the markdown anymore. I give them the problem statement and expect them to give me the markdown of their plan. Then I read that plan as if I'm an engineering manager to say, does this engineer understand the problem that I've given to them? And I critique their plan. So I critique the markdown. And then once I've had the conversation with the agent about their markdown and I'm satisfied with their markdown, then I say build, right? And all of the modern tools, anti-gravity, cursor, all of them now have plan mode, and so that the skill that I'm focusing on, and I'm going to say this, please, 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 if you're an engineer listening to this podcast, absolutely get good at describing problems, and reading implementation plans. Now, this is something you already should have been good at before AI existed, is reading implementation plans of your fellow developers and learning how to critique them. That is a skill that every engineer needs to have, and it's that much more important now in the age of AI coding agents.
Fascinating because uh, advice I've given to engineers earlier in their career, Brad, when they say, how do I get ahead and so on and so forth? I say, look, get good at writing an implementation plan.
Yep.
Like once that's to me, that's like the key thing. If you can make a plan, if you can understand, so to write a plan, you got to know what is being asked of you, and you got to understand how your system works so that you can know how to build it. And if you can write a plan, then you're at a fork in the road. You can get leverage from other people and inviting other people in. Essentially, you're becoming a lead or a manager, or you can write more and more sophisticated plans and become more and more of a climb up the engineering track, right? And it's interesting what you say there is it shifts from writing the plan to being able to evaluate the plan.
Yeah. Yeah. Well, and to think about that, like if you were going to write a plan, before you could write a plan, you have to be able to also evaluate your own plan. Right? Like, how do you know that your plan's a good plan? Is you're effectively self-evaluating your plan. And to your point, Scott, like self-evaluating your plan, you have to understand, do you understand the thing you're being asked to do? So you got to get really good at understanding how to ask things, how to understand what you're being asked for, right? That's one of the important skills. And then the other important skill that you described is understanding enough about your system to be able to just to think about how to mutate that system, right?
Mhm.
And so this is like job one of the first week of every engineer on a new team is they'd better focus on, do I understand the system I'm about to start working on, and how quickly can I get up to speed on learning this system, learning its architecture, learning the data model, potentially learning its quirks and weaknesses and strengths, and then I have the ability to start writing code, right? Like if I don't understand the system I'm working on, I can't think about it, about how to mutate it. I can't reason about how to mutate it. And so more than ever, I'm thinking like that's how you that's how I believe you have to interact with this AI is it's like another developer on your team. And so how would you participate in assisting another developer building a feature on your code base?
I want to riff for a second on the understanding the code. In the last couple of weeks, someone at our company hooked up an AI chatbot into Slack, which, however they did it, has awareness of our code base. And so now we're seeing people ask questions like this. Um, where can I find the name for the partner in invoices? And it responds with some answer like, here's where it is in the code. Or what are the definitions of user suppression levels and where can I find them? And that's pretty interesting. Both of those questions were asked not by engineers, by other people in the company who needed that information for something. Um, but we're giving engineers, you said, okay, you start on a new team, you go in and try to understand the code. We've abstracted that away. Now we're abstracting it away from even the engineer needing to understand the code. And now the folks outside of engineering can do it, which is pretty cool. Okay, let me pose another question to y'all. Paul, you were a manager of engineers at Salesforce for a long time. There is, it seems like in the field, pockets of apprehension, if not downright resistance. And I can understand that. I think it was Upton Sinclair who once famously said, it's hard to get someone to understand something when their salary depends upon not understanding it. And that's what a lot of these engineers feel like. What's your take on, as engineering leaders, engineering managers, if we should be mandating, basically forcing people to use these tools? That's a question I've been struggling with for the last, say, 3 to 6 months. Is should I just, I don't know how I would make my team do it. I can't force their fingers to type certain things, but I've been pondering that question. What's your take on that?
Gotcha. Well, there's the Spotify memo, right? Which is,
Hmm.
before you come and ask me for money or a head count, you know, be prepared to provide an argument for why you couldn't get this done with AI. So I think, um, the resistance is due to a sense of disempowerment or some kind of hypothesis on that the AI is going to somehow supplant the engineer, and I think that's misplaced. Right? It's a new tool. It's a way to magnify your impact, right? To multiply your effort. Um, and I think people really need to um, go into it with the mindset of how do I make this work versus why didn't it work when I tried something?
Mm.
Because it definitely can be made to work, and the potential gains are significant. And it's not that it's going to replace you; it's that it's going to multiply you. It's going to exponentiate you. If you're starting at 0, you can get to 1. If you're starting at 1, 2, starting at 2, 4. So I think this, like, you didn't like typing a giant YAML document to feed to something. Like, great, get the AI to do that, right? But the person who's in charge of figuring out what the AI should do, how to connect that to the business and what's supposed to happen, that's you. Um, so yeah, grab that tool and get busy.
Another bit of resistance I get, here's a quote I just got this week in a Slack message. AI generated code isn't good enough yet for complex business logic.
They're just wrong, Scott.
Yeah.
They're just wrong.
Would you mandate it? And if so, how?
Okay, so here's my quick answer. I have not mandated it in the teams that I'm working with, but I do say to every single person, both in team meetings and one-on-ones, look, man, we got to move fast. We got to move fast. Right. I work in startups, so it's all about moving fast. We got limited runway. We got to like make something happen, And so it's like, we got to move fast, and I need you to be moving as fast as you possibly can. And, you know, I mean, there's, a bunch of my teams that I work with, like, they see me doing it. Like I'm a player coach, right? I'm actually also writing code, and they see that it's like I already was a fast developer, and they just see me easily 10 times faster. And so it's just like, look, we got to move fast. And so I feel like if you don't see other people being productive, if you see other people and you don't see that they're being more productive with it, and you genuinely are missing out on that, like you're missing that, it's not apparent to you what is happening to the rest of the team making great strides on this, then you're probably not a good fit for the team already, right? Like that you're already sort of signaling that you're not a good fit for the team, right? So I don't think it's about mandating. It's more like, this is what we're doing. We're moving fast. We're a team. We're burning daylight. Let's move, right?
Yeah,
So that's my take.
and I agree with, like, the burning daylight is um, a great analogy. Like, we've got some place to go. We need to get there with the boots we have on the ground. Um, I think it's useful to pivot back and forth between the why and the how, like I was saying, Scott. And when you find somebody with an objection like that, and I've chatted with some friends who work on like legacy C++ code bases, and the comment was like, "Oh my God, no! Like, don't let anything near that code." Like, well, why do you say that? It's like, well, there are so many undocumented invariants and so much tribal knowledge, and so that actually, like, wow, I would love to itemize that technical debt. I would love to find a way to burn it down. Like, I've got, 50 headcount. Like, let's throw some money at some of these tools and start doing those things to rein in, those areas of unknown. Um, but I think just a little bit of pivoting back and forth between, why and how. Like, well, why not? Well, how do we solve that? And enough applications of that will get you somewhere where you can be productive.
Yeah. And I'll just say, like, I think that it was on one of the earlier episodes of the podcast that we did when we talked to, I don't remember who it was, but they made the point, like, if you tried this, at the time it was like, if you tried this 6 months ago and you didn't like the results of it, then try it again, right?
Mhm.
And I like it's just getting so much better at hard stuff. Man, I had this bug I had to fix last week, and it was like it was an obscure race condition. It was hard to reproduce, you know, and but I knew the subsystem that it was in, and I had data about like when it fails, these are the signals that I have to know that it's failing. And I threw this at anti-gravity, and basically it came back and it absolutely identified the race condition. It had full flow graphs to saying, here's exactly the race condition that'll exist. If this timing happens this way, this is going to happen, you know. And it came back with a proposed fix, and I was like, okay, I believe you. That's plausible, but my code reviewers aren't going to accept it unless I give them a working example of forcing the race condition. So go back and modify the code, add in the appropriate like delays and timers to cause the race condition to happen, and then they'll believe me that we've fixed it. Because this has been haunting us for like 6 months, you know? And it did it. And it did it in like 30 minutes. And this is a bug that has been haunting us for 6 months. And it's one of the most complex things that you can deal with, like race conditions in asynchronous systems. And it nailed it.
Yeah, that's pretty impressive.
So keep trying. And don't be surprised when it gives you something completely hallucinated, like making up an API call that doesn't exist, because it's still going to
Yeah,
do that.
Yeah,
yeah.
interesting.
There's somewhere under the hood is something stochastic. So,
Yeah.
but
Yeah. Yeah. It's still probabilistic. It's not actually deterministic.
I have a technical question for you, Brad. You know how you were talking a few minutes ago about how you were interacting with, I don't know which model it was, and it was telling you what it was thinking? I actually don't know how it does that part of it. How it has awareness of what it's doing.
This I don't know how much you've looked into this yourself, Paul, and jumping into this. So I feel like I'm a little bit of a naive outsider on this,
Mhm.
but this is my understanding. So one of the biggest advances that I've seen that's happened in the last uh I'll say year is that this is what we talk about. The latest models are agentic friendly, right? That's kind of the
Mm.
language that you hear in in the frontier model development community, and the sort of like VC space, and sort of like, what are we doing here? And so they say basically like the models are more agentic friendly. And what I understand that to be, and you can see it in Cursor and you can see it in Antigraph, you can basically see it in these IDEs, is they started like exposing this, I think, to those power users like us that wanted to like see it thinking.
Mm.
And what it is basically that the LLMs that are agentic friendly, they have they basically you can hook them with, if you need to run a tool, this is a tool that does the following, right? So for example, essentially in the setup of the LLM, they say, here's a tool that will list code for you. Here's a tool that will do a diff for you. Here's a tool that, and they basically give the LLM access to a bunch of tools. And the LLMs are good at going, I understand I doesn't really understand it, but it's like, if I get to the stream of tokens that say I should compare two files,
Mm.
then run this tool and look at the results and expect it to be this way. And so it's this combination of the LLMs happen to be agentic friendly in that they their training and their post training allows them to be good at knowing to instantiate a tool and knowing how to read the results of that tool. And in the IDEs nowadays, they're basically blurring that stuff past you really quickly as it's working. So you'll literally like I've got this race condition bug. I know it's in this code, right? It says, you'll see, like, blink on the screen real quick. The user wants me to find a fix to a asynchronous race condition bug. I am going to analyze the code in the modules that they said. Let me search for this keyword that the user uses. I'm now searching for this keyword. I've now found it in this file. Let me read that file. I am reading that file. I'm comparing that file to the last version that they said the race condition didn't exist in. It's basically spinning all that, and it's just the model kind of like eating its own tail, feeding
It's
on
like
itself.
narrating itself.
It's narrating itself. Yeah. So
Yeah.
Just fascinating to me.
so that's what I mean when I say it's thinking through. And Paul, you mentioned that same thing. You could see like when your Avalanche app was trying to do it, you could see it was spinning out on trying to solve a piece of the problem.
Yeah, oh, I'm doing this, I'm doing that, and there's that aspect of recursion. Back in the first days of the generative approaches, right? It was strictly input and output, and then people started kind of looping it back. It's like, okay, well, generate a plan based on the prompt, and then you kind of work your way down as generate this like gradual escalation of capability until you get to something that you know how to do. Like, oh, yeah, hey, I know how to read a file. I know how to look up something in a database. Um, those things can kind of take you sideways, right? If you don't have the right set of tools at your disposal, you can do something like read the entire database instead of writing a query to get the information that you need. But yeah, that whole space and the fact that it works, sort of interesting and really magic. And there's so many cool. Like, I have yet to spend much time exploring multimodal AI, and really curious about things like ternary LLMs, right? The possibility to compress this sort of approach to problem solving down to places where you don't need a GPU anymore, and it's suitable for you put in your light switch, smart light switch.
Yeah.
So yeah, I think there's so much cool stuff out there.
Totally. Yeah.
Well, Brad,
Yeah.
should we end
Okay.
with our AI game? I'm going to bring up Hacker News.
Don't look, Paul.
Oh.
The game only works if you don't look at Hacker News yourself. So.
Oh, okay. Yeah, not that kind of looking. Okay, I'm not looking.
I am looking at Hacker News. How many of the top 10 articles are about AI?
Oh, 10.
No, I'm taking the under. I'm taking the under on that.
Taking
Let's
the under.
see.
Well, I'm trying to think like what has happened recently. Like, there's been no big Cloudflare outage. Shai Hulud is weeks ago. Netflix is buying Warner Brothers. That's probably not going to show up on Hacker News unless there's some show that people won't be able to watch that they really like. Yeah, I think my guess is still going to be high. You think 10's wrong?
10's too high. I'm gonna go with. Wait, I'm gonna go. Here's my guess. I'm taking the under, but I'm gonna be even bold. So we'll see how much the spread. I'm gonna go 4. 4 of the top 10 articles are about AI.
Okay, number 1, Netflix to acquire Warner Brothers.
Look at that.
Number 2, Cloudflare outage on December 5th.
There you go. So far, no AI.
Number 3, Gemini 3 Pro, the frontier of vision AI.
There we go. That's an AI.
Cool.
That's one.
Yeah.
Number 4, item potency keys for exactly once processing.
No, not AI.
No. Yeah.
Number 5, perpetual futures. I don't know what it's about, but the URL is bitsaboutmoney.com. So I'm going to say no AI.
Might be crypto related.
Could be. Number 6, Frank Gehry has died.
Whoa.
Age 96.
Not about it.
I hadn't heard that, but there you go.
Pardon me. Number 7, BizBuzz in CSS. That's almost like the opposite of AI.
BizBuzz in CSS. That's awesome. So that's really cool. I want to see that program.
So I have to comment though. So the last time I got a chance to go back to programming, which was nearly 20 years ago, FizzBuzz was all the rage. Wrote a FizzBuzz in Haskell before writing some other stuff in Haskell. But it's just hilarious to me that FizzBuzz is still out there.
By the way, I think we both are at this point. There's no chance that it's even 4, right? Because you're at 7 and we got 1.
Yep. Yeah, the price is wrong.
Yep. Number 8, useful for you, Paul. Patterns for defensive programming in Rust.
Wow, like it?
I thought, wait, Jose, I thought the whole point of Rust was you didn't need defensive programming because the language guaranteed you couldn't screw up.
No. The language with the right idiom and flag will do that, but it's like Scala, right? There's plenty of rope to tie yourself up if you want.
Fair enough.
It
All right,
really is.
number 10.
Oh, we're on number 9.
Oh, okay, number 9.
Framework sponsors Catchy OS. I had to click on that link because I didn't even know what that meant. Hey, Catchy OS community, we have some massive news to share today. Framework, the company behind the modular and repairable laptop revolution, is now sponsoring Catchy OS. So I don't really know what that's about. Number 10 should almost be the entire theme of this entire podcast in its entirety from since we started, Brad.
Okay.
Most technical problems are people problems.
Yes. Accurate. Accurate. Maybe AI. There might be some AI in there.
A blog post by a guy named Joe Schrag, who I've never heard of before, writes about that. So there you go. That's the AI game for today. Apparently, AI is going bust.
Only 1 out of 10. Paul, I definitely should not have taken your money on this one because I knew right out of the gate that you were a rookie at this game when you said 10. Like it's
I was not briefed on the game. That's okay.
The rules were clear. You guess how many articles in the top 10 are about AI. Well, Paul, thanks for coming on the pod. Thanks for talking to us about this. I actually feel like I'm, in the camp of like using AI to speed up developers and to build software faster and more reliably. I am quite bullish, and I love that you kind of decided to dive in and kind of like learn for yourself, like really kind of test it and experience it. And I love that you kind of came with these, the approach that you took, and it's pretty exciting that you're out there attacking this. And so thanks for sharing your experience.
Oh, no, thank you for having me. Thank you, Brad, for having me on. I mean, this is just it's so fun, and I feel like there's kind of some of that giddy joy of making software again. So yeah, thank you very much.
Cool. So how do we summarize this? Everybody, if you're skeptical about AI code, just discover the giddy joy of writing software again. That's the words of wisdom from Paul Brown.
Oh,
right. And then smash, rate, and subscribe.
Smash that subscribe button, rate and review, and tune in next week to another episode of the How Many CTOs Does It Take podcast.
Everyone.
awesome.
This episode of How Many CTOs Does It Take podcast was edited by Saffron Hefta-Gaub. Our theme song was AI generated by Brad. Please follow us on all the social media platforms at How Many CTOs Pod. You can find us on YouTube, LinkedIn, Instagram, Facebook, Threads, X, TikTok, and Patreon, or at our website at howmanyctospod.com. And remember to rate, review, and subscribe on the podcast platform of your choice. Thanks for listening.